Hello everyone. Today this video will show you the design and the loads of applications of operational amplifier. So today is tutorial 1, basic application of operational amplifier, and all operational amplifier will be verified in National Instrument Multisim software. Now this is the operational amplifier configuration. So ideal op-amp will have the infinite voltage gain, infinity high impedance, zero voltage impedance, and its gain is independent of input frequency. It has zero voltage offset. Its output can swing positive or negative to the same voltages as supply reaches, and its output swing instantly to the correct value. Now, starting with the inverting amplifier, we know the theory says that whenever you apply the input voltage, output voltage is 180 degree out of phase, means positive is converted into the negative half cycle. It is called inverting amplifier. So in the circuit diagram you can see the input resistance is connected to the negative terminal of the op-amp, and feedback resistance is connected output terminal to the input of the op-amp, and the positive terminal is grounded because we need a phase shifting or the inversion of the signal from coming from the input. So that's why the signal is directly given to the minus of the amplifier and positive is grounded. So now let us start, and one more thing is this is the equation of the inverting amplifier. So how the gain voltage is set to the amplifier. A is equal to minus Rf divided by input resistance. Now let us verify the design data of the inverter amplifier. Now take the parameters of amplifier. R input is equal to 1 kilo ohm. Rf feedback resistance is equal to 10 kilo ohm, and input voltage VDC is 2 volts. Now try to simulate this inverting. I have multi-sim simulating software. You can download this. I have applied the link into video description. Now go to the place component, and you see in the sources lots of components are available. Sources, basic, diode, transistor, analog, TTL. Now we need a 741 op-amp. So you can go to the select all and write here 741. So you will be find the symbol of op-amp. You can take the symbol. Now take the VCC as a voltage supply. Take VEE for the negative biasing voltage, and another to take AC power for the input supply, and resistor and ground. Now we have taken the all component which is required to design the inverting amplifier. Now I am connecting all the components as I have shown in the PPT. Now you can copy this resistor also. By this way you can paste. You can rotate each and every component the multi-sim window. Now I need a zoom the circuit so it must be visible for all. It is visible to all. Now I am taking the 1 voltage as the input voltage and 50 Hz frequency, and according to the datasheet of 741 we can apply the biasing voltage as a 12 voltage plus and minus 12 voltage. Now this is the feedback resistance I will connect here, and it is given to the input of negative op amp, and I will change the label name RF feedback resistance, and this is input resistance. So now I will change the values also. I will set only the 1 kilo ohm feedback resistance. I am setting on a 10 kilo ohm. So output voltage will be a 10 times of input voltage according to the equations. Now on right hand side you can find the oscilloscope. This is the symbol of oscilloscope. You can connect A channel with the output voltage and P channel with the input voltage. So you can compare both the input and output voltage at the same window. Now running the simulation, you see here this is the actual performance of 741. So you see the sinusoidal signal, it is showing the input voltage 1 voltage magnitude at the channel B, but the output voltage is somehow saturated. It means our input voltage and the gain value is so designed that the value is beyond the biasing voltage 12 voltage. So we need to redesign our circuit so that our output voltage must be in a limit. So for that one I can change the voltage as well as the feedback resistance. So I am going to change the gain of the amplifier. I will reduce the gain as a 5 kilo ohm. So my output should be in a 5 times of input voltage. So now see the output voltage. Now it is coming, means it is not going to saturate it. Now you can see also the magnitude of output voltage is going higher compared to the input voltage, and it is a inverted signal. You can see here the negative with the positive phase change. So this is the working of inverting amplifier. The both function we have done, we have changed the phase value and we have amplified the input signal. Okay, now after performing the inverting amplifier, we came to know that the biasing voltage importance, because once you have selected the biasing voltage, then if your input voltage is more than biasing voltage, so output of the amplifier is going to saturate it. So this is the advantage of the amplifier, or we can say it is also one kind of disadvantage that your input voltage may suffer the saturation level by the amplifier. Now next is non-inverting amplifier. In this non-inverting amplifier, we know that the input signal is, suppose this is the input signal and the output signal, it is the same, but the thing is that you can change the magnitude of the output voltage or the signal, whether it is DC or AC, and this is the feedback resistance, and R2 it is the input resistance of the non-inverting amplifier. So difference between the inverting and non-inverting is that here in this amplifier you see the positive sign is connected input signal to the op amp, and the negative sign is grounded through the resistance, so that your signal is not going to shift their phases or the voltage sign of the DC voltage. So now one by one you can take the parameter. Let's say I will select the one, suppose I will select RF feedback resistance as a value of 5 kilo ohm, and second the R2 resistance I will select as a 1 kilo ohm, and 3 the voltage 1 input voltage I will take the 2 voltage RMS. Now according to the equation, this will be going to perform the output voltage. Now let us verify this circuit, non-inverting amplifier. Now this is the multisim simulating software again. Now go to the place component and again find out the all the material is required to make the non-inverting amplifier. So before we have taken the AC supply, so again we will select the AC voltage here. So this is AC voltage and the resistance again down. This is AC voltage for biasing purpose. VEE for negative biasing. Okay, now connect all the component. I'm going to rotate this one. Okay, now component all the component. Connect all the component. This voltage is 12 voltage as we discussed earlier. 12 voltage. Now remember the connection. Positive is connected the input voltage and the feedback resistance is going to negative of the terminal and R2 resistance is grounded. So we will do that connection here. This is the input voltage and it will goes to the positive terminal of the op-amp because we need a non-inverting amplifier and the VRMS voltage it is a 2 voltage and the frequency is 50 Hz and the other items as it is. Okay. Now this is my feedback resistance, so I will connect at the output and I will change the name label as a RF and I must connect with the negative sign of the op-amp and again I will copy this resistor and paste here because we have to connect one more resistance with the feedback resistance and it should be ground as per the circuit diagram, and we will take the values of the all component which we have described in PPT presentation file. So this is the 5 kilo ohm resistance, this is 1 kilo ohm as it is. Now take the oscilloscope from the right hand side, you can find this signal oscilloscope here and you can connect the A as the output and B is the input signal so that you can compare both input and output. You must remember A signal is output and B is input. Now running the simulation, now you see here somehow your voltage is going to saturated because still the amplifier equation is not going to satisfy. Before we have connected the series resistance, so some voltage is dropped across the resistance. So here there is a no resistance, so total voltage is going to the non-inverting amplifier. So for the protection purpose or simplicity, we will going to reduce the input voltage. Let's say 1 voltage. Now you can see here in the signal it is showing the non-inverting because both the input and output phase is matched with the signal input and output voltage. So that's why it is called as a non-inverting amplifier. And you can check also the magnitude. The B channel have the low magnitude and A channel have the higher magnitude because it is a amplifier. And we can also change the magnitude. Suppose we are reducing the feedback resistance, so output will be going to change. You see the difference in a feedback resistance. The gain property of amplifier will change the output voltage magnitude. So this is the working of non-inverting amplifier. Now after completing non-inverting amplifier, third one is summing adder. This circuit have the two advantage. it can called as a summing amplifier or added circuit. So advantage is that you can add the number of voltages to the amplifier and it will give the summation of output voltage. So you can see in picture also the number of input voltage is given to the circuit from the V1, V2, V3. So output voltage it will be a sum of the V1 plus V2 plus V3 voltage. So we are going to perform this summing or adder circuit in multi-sim simulating. Now we will remove the connection of all we have performed for the non-inverting. Now let's say for performing the non-inverting amplifier, sorry, adder circuit. So we will take this time as a DC supply instead of the AC for the new example. Let's say this is DC supply we have, and we will just copy this and paste here. We are just try to make the circuit of adder. Now all the connection should goes to the negative of the amplifier. See, this is all are the DC input. So value you can take 1 voltage and also 1 voltage. Now remembering the circuit, we need also input resistance before it must connected with the amplifier and only the one single feedback resistance. Now try to make this circuit. We have only the single feedback resistance. So connect feedback resistance here and remove this. So now we have the circuit, but we need the input resistance for the all individual supply. So we have to take again resistance. We copy this resistance and paste here. Try to rotate this. Okay, now this is here and paste resistance. Okay, now finally we made the circuit diagram of the summer or adder circuit. As we have seen in the PPT file, the two inputs we have taken for the reference, and this is the feedback resistance we have connected between the output and input. And again we know that the both signals are connected with the negative sign of the amplifier through the resistance. So the output will be a inverting because we have connected the positive supply, so output will be in a negative because of the negative amplifier. So running the simulation, you see the output voltage is negative line below the zero value because we have connected the negative supply over here. So we have to verify this circuit is working as an adder circuit or not. Mathematically we know 1 plus 1 is equal to 2 voltage, but output must be a practical, so we can take the probe and we will check the output voltage from here. So this is a one display. Using this display you can measure the output voltage. So we need only V voltage. So this is the V output voltage. We will change the font, making them visible. So this is my probe. Output voltage must be at 2 voltage. Running the simulation. So you can see here the output voltage is coming minus 2 voltage. So this circuit is working properly and the perfect value. Now suppose we going to change the value. Let's say this is 5 voltage. So output voltage mathematically it should be a 6. 1 plus 1, 5 plus 1 voltage is equal to 6. So now you see here the output voltage is 6 voltage and minus 6 because of inverting amplifier is connected. Okay, now after performing the summing or adder circuit, next is subtractor. So as the name suggested, subtractor means it will subtract the two values V2 minus V1 voltages. So we are going to make this circuit in multisim again. So try to remember the circuit. Feedback resistance R3 is connected negative of the sign and R1 through the V1 input voltage and V2 voltage is connected series with the R2 and R4. It is a grounded resistance which is connected positive of the op amp. Now making this circuit again R1 and R2 through the signals. You see this is connected. Now we will connect by this way. So this is the feedback resistance. As the circuit is here, V2 voltage directly positive, negative feedback resistance and the R4 with the positive terminal is grounded. So here we have to take the R4 voltage. So copy and paste here. So this is my R4 volt resistance and it is grounded. Now try to verify the circuit with the PPT. Input voltage R1, R2, R4 is grounded and R3 is the feedback resistance. Now our circuit is ready. Now we will take the resistance R4 as a 1 kilo ohm. Now running this simulation. Now you see here it is working perfectly. 5 voltage minus 1 voltage. Sorry, 1 voltage minus 5 voltage because 1 is connected positive with the op amp and minus is connected 5 voltage with the op amp. So we are getting the 4.33 voltage. So this is the perfect subtractor circuit using the op amp. Suppose it is a not purely 4 voltage, so you can change the value of 1 kilo ohm resistance by 0.5. So you see the change, you see the difference. So it is going increases. So it is better to take again 1.5 to reduce the output voltage deficiency. Again take the 2 kilo ohm. So now it is running perfectly 1 minus 5 voltage as a 4 voltage. Now suppose again changing the value, I am doing the 1 voltage instead of 4 voltage and I am taking here 3 voltage. So as now the mathematically 4 voltage minus 3 voltage will be equal to 1 voltage. So let's start the simulation. So output voltage is 1 voltage. So now this open circuit is working as a follower. So this is the very simple operational amplifier application because whatever you give the input voltage, it will be equal to the output voltage. So there is a no gain, no change in amplitude, no change in frequency. So this is basically used in an industry where you need a direct non-isolated voltage measurement or current measurement. So let us start to perform the unity follower in the multisim. So it is very simple. We will remove all the connections because it is a very easy. There is a no feedback resistance. So we will remove the feedback resistance. Now this is directly connected with the output, and input is connected with the positive of the op-amp. So you see here there is a no feedback resistance, so it will perform as a unity follower op-amp. Now running the simulation, you see input voltage is 4, so our probe is showing the 4 voltage. There is a no change in a sign because we have connected 4 voltage with the positive of the op-amp, so there is a no process of inverting amplifier. Now for example, we are changing the interconnection between the op-amp. Positive is the feedback and negative is connected with supply of the signal, so it will work as an inverting amplifier as a unity op-amp. So output voltage must be a -4. We will see, try to run the simulation. You see here the output voltage is coming -11.1 voltage because we have done the inverting amplifier, so our output is going to saturated. So this why the unity gain follower op-amp, it is always work in a positive connection. So you just do the revert connection and try to simulate. So it is coming perfectly. Now to change the value 5 voltage, so output voltage is 5 voltage. Okay. Now this is the working of unity or feedback follower. Okay, thank you everyone.